Hi everyone, welcome back. Today I want to continue talking about my introduction to serial RFID, and I'm going to focus strictly on the hardware so that you can kind of get an introduction to it and understand what you're about to get into. It's not really that difficult, but like all things, you're curious and you need to know and be satisfied before you invest time and effort. So let's start. Let's start from the perspective of the USB port. That's where the hardware starts, other than the computer, of course. So the USB port, you plug in this little RS-485 adapter. Um, they're not literally a dime a dozen, but they're very cheap. You buy them in packs of 10. I think you can buy them individually too, but they're cheap. You plug it in, and that converts your USB port into a serial port, basically, and it allows you to attach two wires here. Now, on the flip side of this, the red wire you'll see is labeled A, and the black wire is labeled as B. This is standard terminology for RS-485, so I just followed along with that in my scheme of things. So you just plug it in, and your serial port's ready to go. Windows will automatically recognize that device and see it as a serial port. And here's the card. First view of the card. And let me just show you a perspective of the size of this card, because I kind of blew it up here for visuals. But here's the actual card. So you can see it fits in my hand, right? It's not huge. So you get these cards, and you can have up to 25 of them. So you can support a good size layout with these readers. By the way, that's what I call them, readers. I refer to them in the hardware as a reader. And you can address these from A to Y. Z is a reserved address that I'm keeping back to allow for something like a global address scheme. As this project gets developed more, somebody may say, hey, you know what, we need something where we can broadcast to every one of our readers at the same time. So I held back the letter Z for that purpose. So I marked this card with the great big letters A over here. And I recommend, of course, that you do the same thing. Now let's tie it back to where we left the USB port. Remember I told you that the red wire was A and the black wire was B. Well, this is the other end of that USB adapter. So that red-black wire is coming in and terminals labeled A and B. The rest of the network is daisy chained from this connection right here. So this red wire and yellow wire go out to the next card. And it's always simply A to A, B to B. You never have to cross the wires. It's strictly A all the way down the network, B all the way down the network. Never cross the wires. You do need to use twisted pair wire. It really cuts down on the noise and gives more length to the wire that you can use. And it's standard. Standard twisted pair. It works just fine. Now the terminal strip up here at the top is where you're going to apply your DC voltage. And I built this card to operate around 12 volts. So you put 12 volts in here, the positive on VCC and the negative on ground. And it comes into the board to this regulator chip. This regulator chip knocks it down to 5 volts so that the Nano can use it. Pardon me. The Nano then supplies 3.5 volts out to the reader card, the actual MyFair reader card, which operates at 3.5 volts. So we don't have to do anything special there. It doesn't require a whole lot of power, and the Nano handles it just fine. Now if I move my picture here just a little bit, you can see another connector. This is the connector that's going out to the liquid crystal display, the LCD. And I'll point something out to you real quick here while we're talking about these. You notice in this picture, I didn't mark anything yet. These are not foolproof connections. They can be put on backwards. I did that just to keep the cost down. Right? Because, you know, when you get those idiot-proof things, you pay for them. So, put it on. Make sure you use my labels here, the SDA and the 3.3 volt. The matching MyFair card is labeled the same way. So make sure, you know, the white wire is on SDA and the blue wire is on your 3.3 volts on the opposite end. I would recommend, and I didn't do it in time for this video, that you take some fingernail polish and put a dab. I usually put it on the power end. So drop a little red fingernail polish or whatever your choice is down here. That would make it easier in the future if you pull that off to put it back on without having to, you know, do a lot of work in figuring out which is which. And the same is true down here on this connector. You need to put that dab of fingernail polish on it. This 8-pin terminal strip goes out to the local control panel, which you'll see more of in just a minute. And then you have a MAX 485 chip. Now, this is, you might say this is a traffic light or a traffic cop, whatever you want to make the analogy to. We use this to determine who gets to talk on the serial network, because only one person at a time can talk. All of them are listening, but only one is allowed to talk. And in serial communications, this is often referred to as polling, and polling uses what they call the token. The server will send out a packet of information that's addressed. Everybody listens, but everybody says, is this my address? So they compare it to their address, and if it is, they obey that command and reply back. If it's not addressed to them, they simply toss that message in the trash can. So this chip here says, I need to talk, and it pulls it out of the listening mode and puts it into the transmit mode so that the Nano can push its information out onto the network and send it up to the server. Everybody else stays in the listen mode and doesn't interfere. So probably more than you wanted to know, but I felt I needed to tell you about it. Here you can see the daisy chain. You can see my twisted pair coming off of my reader A into A and B, and twisted pair down under the table coming up over here to A and B, and back here to A and B, and up here to A and B. I also just daisy chained my 12 volts. You can see it daisy chained here. So my 12 volts is applied to each of the boards. And I labeled each card. So A is out of sight, B is right here, card C, D, and E. So my little test platform has got 5 cards hooked up. Now, only on my reader card have I got it fully hooked up. These are missing the other pieces of hardware. The MyFair card would be connected here, and the LCD display would be connected here. I have them, they're available, but I just, you know, for the simplicity of just testing the network and everything, I didn't put them up. One important thing you need to do when you use serial communications like this is you have to do what they call terminate the network. And you terminate the network with a resistor. And the reason for that is when the signal gets all the way down to the end of that wire, it will sometimes want to bounce back and go try to travel back up the wire. Well, now you've got two-way traffic on a one-way street, and you have a collision, and that's called noise, and it destroys the ability of the nano chip to be able to read the data, and it loses its intelligence. So that resistor at the end absorbs that signal so that it doesn't bounce back up the wire. And it needs to be terminated with a 120 ohm resistor. Well, I didn't have a 120 ohm resistor. I had 220 ohm resistors right here. See, red represents the number 2, so it's red, red. Brown represents the number 1. So I have 1, 0, right? So it's 2, 2, 0, 220 ohms. And when you put two of them together like this and twist them together in parallel, in the world of resistance, it halves the resistance. So I have 120 ohms across the end of my termination here. And that's to prevent that noise. And believe me, if it's not there, you're going to know it because your network's not going to work. Now, when I was pointing out to you the hardware a little earlier, I did miss something. So I'm going to interrupt. I'm not talking about the network now, but I'm talking about still the hardware. There's 2 resistors up here that I forgot to mention. Those are onboard resistors that work with the red and the green LED if you elect to use them. They're optional. You don't necessarily have to have them, but if you want to use them, they're available, and their use will be explained later in the videos. Here's the local control panel. I printed this on my 3D printer. I'll include the STL file, so if you like my little design, you can use it, or you can modify it and make your own. So, but let's go over this a little bit. First, of course, there's 2 mounting holes, so you can screw it to a table, whatever you're going to do with it. A big wide open area here where you can put a nice label that says this is location XYZ, whatever you want to name it. On my little test layout, I don't have my power through a power switch, but this is so you could turn a reader on and off. You put the power to it out here and you can power that unit up and down. Then the rest of them you need to actually do the functions of the program. When you first get the program and you install it, it has nothing in the database. I say nothing. It has two things in it. It has a default engine and it has a default location. Since I'm going to be working with engines and working with locations, I have to start with something. So I put a default engine and a default location built into the database. So when you fire it up, there's something there to start working with. But your reader comes out of the box stupid. Right? That little nano chip has no idea what it's hooked to, what it's talking to. It's dumb. So first thing you do when you want to use the reader is you roll an engine up over it and you assign the engine to the reader. The reader says, okay, now I'm getting smarter. I now know that I'm going to be working with this engine and the cars that are on it. And I'm going to work with the default location selected. I'm going to be working with this location myself. I'm going to be working with myself. So that now there's a relationship formed between this reader's location and the engine that's sitting at it. But the first time out of the box, this is unique. First time out of the box, when you roll an engine up on here and push assign, that nano is going to tell the server, hey, check if this is an engine and it's valid to use. Well, guess what? That engine is not in the database. So now you got to catch 22. So the first time out of the box, when you power this reader up, you push the assign button with nothing on it. The nano then says, I have nothing on me. I must be new to the system. It will insert the little magic number for the default permanent engine and send it up to the server and say, hey, I want to use the default built-in engine to start with. And then the server will answer back and say, sure, I understand what you're doing. Let's just get started. Now you can roll cars up on it and begin to pick up and drop off cars. Right? So if you have nothing at this location, you would now roll the first car up. When the LCD screen said, shows you the information of the car, then you could push the drop off button. This reader then will take the RFID tag number from that piece of rolling stock, send it up to the computer and say, hey, take this car off this engine and drop it at this location. So the server puts that in the database and remembers that. Now, your worksheet may say, okay, now I got to pull the car from this location. So you run around, you pick the car up, you bring it over, and you put it over the reader. And again, when the LCD display shows you the information about that car, you would pick up that car. Then the nano will send that RFID tag up to the database and say, hey, pull it out of the database, pull it out of this location, and attach it to this engine. So the server does that. And then you can drag that piece of equipment with you to the next location where you'll probably drop it off. So we've covered everything except the release. Now the release you're going to use every time. When you roll a car or an engine up over that reader, the LCD display will pick it up and show it to you and say, hey, this is what's physically on my reader right now. At that point, I lock the reader so that it doesn't try to continuously read that tag. It just stores that information to work with. So now you can drop it off, pick it up, assign it, whatever you need to do. When you're finished with that car, you have to release that car. So Nano says, okay, I'm now prepared to read the next piece of rolling stock. So you pull that current car off and put the next car on. Boom, it'll read it up and lock that information in. So let's go over this real quick without a lot of nonsense talk in between. When you get to we're going to assume that you're up and running, that you've been using the layout for a while. So you roll your engine up. You assign that engine to this location. You pull the engine forward and you release the engine. Then you roll the next car up and the LCD display says, boom, oh, now I know I've got a car here. So now you can drop that car off. Boom, you drop that car off, you release that car from the Nano. Perhaps you go pick a car up and you want to take it with you. You roll that car over the reader when the LCD display shows it, then you pick it up. Boom, it moves it around in the database. You release that car, you drive off to the next location. I think that's pretty clear. You use it once or twice and it becomes second nature, and it's not a real problem. When your brain actually sees it all in front of you, it clears up the mud. Okay, all that mud filters down and settles in the bottom. And it's moved forward now. All right, so here's a display of my little test setup. So here you can see the LCD display, and it says Happy Holidays Boxcar, and it's green in color. And if you look at the boxcar, you can see it's predominantly green in color, and the markings on it says Happy Holidays. Well, of course, you know, if this were another car, this might be a Union Pacific 1, 2, 3, 4 or something of that nature. Well, that would be displayed here as well. So I want to take a moment here and just for a little personal thing. If you look on the side of this car, it says the Houston Museum of Natural Science. Well, here in Houston, every year, this museum runs train layouts. And it does it as a promotion, of course. And you can go down to the museum and you can look at these wonderful little, not little, but these wonderful train exhibits. And as a fundraiser, you can make a donation. And if you make a donation, they will make up a boxcar that says Happy Holidays on it, like this one does. And on the reverse side, it will put the name of the donor. Well, my son did this for me one year. He went down and made a donation. So on the back side of this car, it says Jim and Lydia Kelly. So then he hauled us down to the museum to go look at the trains, and we got the surprise of seeing our car running around on the layout. And after the new year, when the display was taken down, the museum mailed us our car. So I just wanted to share a little personal insight and history. That was a nice gift. And here, this is the fifth line. Because the display can only show 4 lines, I had to toggle the display. So I have a timer. I think it's set at 20 seconds. Every 20 seconds, this screen will toggle. So now it's showing the owner of this piece of rolling stock, which happens to be me. So I simply put Jim. By the way, let me point out here, this LCD can have 20 characters on a line. Unfortunately, a sector in the RFD tag only has room for 16 characters. So I have to limit the number of characters that you can put into it. And I do that. When we get into where you put the data in, I'll remind you again, 16 characters is the limit. Right, just to point it out. Here I flip over that car and you can see the little white tag. I just stuck it up under the body and it reads just fine. You can write to it just fine. Not an issue. Everything worked great. Here was my troublemaker. I talked to you a little in the introductory video about the cheap little cars that that might come as a Christmas gift. Well, this whole undercarriage here, this is all metal, and metal has the problem of absorbing the radio frequency field, so that there's too much interference for the antenna in here to get a strong enough signal to see it. Well, I discovered that. I took this tag. Before I put it here, I'd had it mounted right here in the underbelly. Okay, but it wouldn't read. So I moved it and I stuck it onto the decoupling body of the coupler, and it works just fine there. So even with a heavy metal body, you can put a tag on it. And then this is one of those more expensive tags that I talked to you about that, you know, they cost a little under $2 each, but they're probably going to be rare in your layout. The others are under $1 each. So let's explore what I did here. Since I had been working with that metal tag, that metal car, I put it over that reader and it wouldn't read. And I thought, problem. Is it because of the metal of the rail here interfering with the reader? So I experimented, and you can see here I cut a chunk of the middle section of the rail out just to troubleshoot. And I mounted this reader over here, and I ran that tag over, still wouldn't read. So then I moved the tag from the belly of the car to the coupler of the car and ran it back, read like a champ. And now I said, all right, it's reading like a champ here. How would it read with the center rail in? So I moved my reader back over here, ran that tag over here, read like a champ. So it was definitely too much metal surrounding that tag that was causing the problem. So that was great. The plastic car body up here with the tag all the way up on the body with the reader mounted here has no problem. Works like a champ. There's no interference from that rail. So don't try to cut out your center rail. I guess is the final word on that. You don't need to. Here I just took everything and flipped it over so you could see that card. Now that's a small enough card. You can see it by the relationship to the rail. It's not a huge card. And these little tags, these come with the reader cards, and I call them my little cheat cards. And I of course use these for development. They were much easier to handle than trying to put rolling stock on and off and on and off, on and off, and changing cards and everything. I just use a card and it worked fine. And it gave me the idea. Well, after maybe doing an ops session or a demo for your neighbors and friends, you want to relocate your stock, and maybe you want to use to speed the process up. Maybe you want to use the 5-finger airlift, where you pick that rolling stock up and you just physically carry it and put it where you want it, and to speed up the process. Well, because to do that you have to use that local reader. You have to assign an engine and pick up that car and then move that engine to the new location, assign that engine, and then drop off that car. Well, it can be time consuming if that's not your goal, if you're not playing with the trains at that time. So use this card, give it an engine number. Right? Make one up, it doesn't matter. Right? Program it into your system as an engine. Then you can just take this, flip it down onto the reader and assign it and say, I'm engine 141. Okay, put your piece of rolling stock over that reader, push pick up, and it picks it up onto the database and says, this car is now on engine 41. 5-finger that car over to your new location, drop that car down on the reader, push assign, the engine is now assigned, put your car down on the reader, put drop off, that piece of stock is now in the database as being located at that location, and go put it out on the rail wherever you want it. Right? So to me it may be a quick little cheat, and I thought I'd just share it with you. You won't ever see this. This is one of my development screens, but just so you can kind of understand how this whole network's going to work, I thought I would share this with you and show it to you. Internally, I developed this command, asterisk capital A 01. That says I want to send command number 1 to reader A. And here, so just before I send it out onto the USB port, I test it again, make sure that I'm really getting out onto the wires what I thought I was sending. Sure enough, I've got a nice clean command going out. Then I wait 200 milliseconds. And the reason for that is all those readers out there. I can have 25 of them out there, and they're all running what they call asynchronously, which means they're not synchronized. They're not always doing the same thing at exactly the same time. It's just like herding cats, right? Everyone's doing their own thing. Who knows why? But they're all listening. So I send that command out on the wire, and they all pick it up. And finally, reader A gets to the point in its program where it says, did a command come in? And yes, it did. And it checks, oh, A, this is assigned to me. And now it has to process that command, put together a response, and shove it back out to the server. That's why I have to delay. And I found out that 200 milliseconds gives me a good solid network that I get I don't get any errors at all at that rate. And so now I can sit there and wait for the message to come back to my reader. And so my message comes back in and I test for it. And when that reader has nothing for me to do, all it does is simply echo back my command. So it echoed back A01, and that told me, oh, this reader had nothing for me to do. And I move on to the next reader, and I send out B01. Do you have anything for me to do? Nope, it echoes back, and it'll continue that process till it gets to a reader where somebody has pushed the assign button or the pick up or the drop off button. And then I'll process those commands as they come in. So that's just a little internal information. Maybe it helps you to understand if you think you're seeing a little lag in your readers, understand you're just waiting your turn to be communicated to. And that really just kind of wraps up everything I have to show you about the hardware. I hope it's been a good overview for you and made life, maybe it's intrigued you, maybe it's made you want to find out more. I hope so. I hope it's something you can use. I'll pick up again. We'll talk next probably about the software. I'll see you later.